UVM is not a programming language, it's a methodology. So our UVM Hello World example is going to be a bit more complicated than a Hello World might be in some other language. To be true to UVM, our Hello World example needs to have a DUT, simple though that may be. We also need an interface to the DUT. This will be a SystemVerilog interface. So our Hello World example is going to be a combination of SystemVerilog module-based code, modules and interfaces, and class-based code. Our class-based code is going to be divided up between an env and a test that is going to exercise that env. So even though this is a trivial example, you'll see this structure, this division between the module-based and the class-based parts already in place. Let's start in the module-based part of the test bench. Here is our interface. As you can see in this trivial example, it's empty, but there is an interface. And here is our DUT. Again, in this trivial example, it's empty, but again, there is a DUT. Notice also that our DUT has an interface port. In a real project, especially if you're testing the top level, it's unlikely that the DUT would have an interface port. Instead, there'd be one or more SystemVerilog interfaces instantiated with the DUT in the top level module. That top level module is called top in this example. You can see that we have instantiated the interface and the DUT inside it, and we've connected the interface to the interface port on the DUT. Now let's start looking at the class-based part of the test bench. So here's our first UVM class. The elements that come from the UVM library are highlighted in red. So the first thing to notice is that we have made our env, which we've called myEnv, by extending a UVM class called UVM-env. There are no rules about what constitutes an env. It might be your top level, it might be some lower level. Basically, an env is used to put hierarchy into the test bench. Then we have a call to a macro, UVM component utils. UVM uses macros a lot. Whenever you extend a component class in UVM, you should call this macro. There are two kinds of class in UVM, component classes and data classes. Component classes are classes that are used to make the test bench out of. We have already seen various examples, UVM-env, UVM-agent, UVM-driver, and so on. We haven't met any data classes yet, but when we do, you'll see that the data classes are used to represent the data that flows through the test bench. In other words, transactions and sequences of transactions. This UVM component utils macro expands to quite a lot of code. The purpose of this macro is to register the component with the factory. What that means is beyond the scope of this webinar, but if you know about OO design patterns, particularly the factory pattern, then you'll already know what this means. What I can explain in this webinar is why you might register a component with the factory. There are two reasons for doing this. Firstly, the configuration database is able to use this information to associate different pieces of configuration information with different parts of the test bench hierarchy. And secondly, the factory is able to easily swap one test bench component for another, which sometimes you'll want to do. Finally, we have the constructor. In UVM, you should always override the constructor when you extend a class, even if there's no extra work for the new constructor to do. Basically, this is boilerplate code, standard code in other words. You should always override the constructor, and you should always call super.new first, and you should always pass the two constructor arguments, name and parent, to super.new. So we've looked at the module-based part of the test bench, the empty interface and empty DUT, both of which are instantiated in the top-level module. We've looked at the env class, which, apart from the boilerplate code, is also empty. Let's have a look at the test, which remember is the top of the object hierarchy, the top level. And, only in this example, env is instantiated in the test. Here is the code for our test. In UVM, you make a test by extending the UVM test class. Remember that a test is a test bench component. An env class is instantiated in it. And so, like with our env class, we need the boilerplate code for component classes, the call to the UVM component utils macro, and the overriding of the constructor. So what do we actually mean by instantiating one component within another? It's obvious with a module, it's not obvious with classes. Well, to instantiate one UVM component within another, you need to do two things. One is to include a reference to that UVM component, in other words, to include the instantiated class, which we'll call the child, as a data member of the class in which it is to be instantiated, which we'll call the parent. The other thing you need to do is to create that child, and we'll see how to do that now. Next, we have overridden a function called build phase. Remember a few slides back I mentioned the various phases and described some of the things that need to be done in those various phases. What I didn't say was how to make something happen in a particular phase. Well, here's the answer to that question. You make something happen in a particular phase by overriding the appropriate method of the class in which you want that something to happen. So to make something happen in the build phase of our test class, we need to override the test class's build phase method and write some code within it. This method will then get called from behind the scenes. So what do we need to do in our test class's build phase? We need to create any component which is instantiated in this class, which in this case is our env class. So in the build phase of our test class, we need to create our env component. So let's have a look at the code that does just that. At this point, you're probably thinking, what the heck? I did mention at the beginning of this webinar that you would need to understand some class-based SystemVerilog code in order to get the most out of this webinar. It isn't my intention, because we don't have the time, to teach you SystemVerilog as well as UVM. But I'll make an exception here. Many SystemVerilog experts would struggle to understand what is going on here. The code on the right-hand side of the assignment operator, the equals sign, returns a reference to an object of class, in this case, myEnv. Notice that the same two arguments are given here as are expected by the constructor of each component class, a name and a reference to the parent component. For the name, always use the same name as the variable that's on the left-hand side of the assignment operator. And what about the parent? This class is the parent, so the reference to the parent is just this. So this code is setting up the reference to our env component, and given that, and the fact that the arguments are the same, it's probably no surprise that this code indirectly calls the constructor of our env class. What the code on the right-hand side is actually doing is calling a method called create, which is a static method of a class called typeID, which is declared inside our env class. What? I don't hear you ask. I didn't notice any declaring of a class called typeID within the myEnv class that you showed me a few slides ago. And you'd be right. Well, again, remember a few slides back, I mentioned that the UVM component utils macro expands to quite a lot of code. Well, some of that code is the declaration of this typeID class. It's legal to declare a class inside another class in SystemVerilog. Such a declaration is called an embedded class declaration. You don't need to know this to use UVM, but if you're anything like me, you like to know a little bit more than you need to in order to understand what it is you do need to know. If you're not like me and would rather not be bothered by this detail, then treat this line of code like a magic spell. Type it in, what you want to happen will happen. In our trivial example, we need to override one more method of our test class, the run phase method. Remember I mentioned that the run phase is the only phase which consumes time and that all of the other phases execute in 0 time? Well, because of this, the run phase method must be a task, whereas all the other phase methods are functions, because you are not allowed to wait in a function, to consume time in other words. So to make something happen in the run phase, we need to override the run phase task. The key thing we need to do in our run phase task is to display the hello world message. We do this using another UVM macro, UVM info. This is one of a set of 4 macros that can be used to display messages with 4 levels of severity that correspond to the SystemVerilog levels of severity: UVM info, UVM warning, UVM error, and UVM fatal. You don't have to use these macros, but it's probably best to use them. One thing you'll find when you start using UVM is that there is often more than one way to do something, and deciding which is the best way to do it causes confusion and wastes your time. For this reason, Doulos has compiled a set of coding guidelines for UVM, which we call Easier UVM. You can find these on the Doulos website at www.doulos.com, as is shown on the slide. The UVM info macro needs 3 arguments. The second, as you can see, is the message itself, hello world. The first argument is called the message ID and is used to facilitate the filtering of messages. You can set this to anything you like. So there's a danger that you can cause confusion and waste your time worrying what to set this to. Easier UVM recommends you set it to the class name and leave it at that. In fact, you don't need to do that manually. As you can see here, there is a method which you inherit from a base class in all of the UVM component classes, which returns the class name as a string, getTypeName. So let's use that. The third argument is the verbosity level. The higher, the less likely that the message will be displayed. Be careful, there's a trap here. It's very easy to set the verbosity level of an important message to UVM high, which means that the message will be less likely to be displayed, because it will only be displayed if the verbosity level of the whole simulation is set to high. Of course, we could have just used $display or $info here, but had we done so, we'd not have been able to use this message filtering and verbosity control, which is a feature of UVM. One of the things that UVM enables you to do. In addition to the essential job that needs to be done, displaying the hello world message, I have also added a short delay. I have done this to demonstrate another feature of UVM, which allows you to control when your simulation stops: objections. Basically, if you run a simulation in UVM without using objections, nothing will happen. The run phase will immediately end. This is because an objection is an objection to the phase ending. In other words, an objection to the simulation ending. Any part of the test bench that wants to prevent the simulation stopping should object to that by raising an objection. Once that part of the test bench is happy for the simulation to stop, then it can drop the objection. If no part of the test bench is objecting to the simulation stopping, then the run phase will end. The idea is that deciding when to stop the simulation is not an easy thing to do. The information required to make that decision is distributed around the test bench. So for example, some component that is generating inputs will know that the simulation should not stop if it knows it still has more inputs to generate. A checker might know that the simulation shouldn't stop because it has seen more expected outputs than actual outputs, and so on. You can see how to raise and drop an objection on the slide. There is a raise objection method and a drop objection method, which need to be called on the object's phase, which you can see is passed into the run phase method, and actually into all of the phase methods. When you call these methods, you need to see who it is that's raising or dropping the objection by passing in the this pointer. Doing so is necessary for various reasons, including helping with debugging objections. I'm sure you can imagine that it is easy to come up with a test bench that stops before it should or doesn't stop when it should. I'm sure you can imagine that you're going to spend some time debugging objections when you use UVM. If you're not the kind of person who likes to be bothered with any more detail than is absolutely necessary, like with the type ID create method, feel free to treat these lines of code like magic spells. Just type them in and they'll do what you want them to do. So we've seen the two classes that make up the class-based part of our test bench. The best place to put class declarations in SystemVerilog is in packages to promote reuse. So let's do that. Here are our two classes declared inside a package called myPackage. Now our classes are derived from UVM base classes, UVM-env and UVM-test. This package won't compile unless the declarations of those classes are in scope. We make that so by wildcard importing the contents of the package called UVM package, which is where all of the declarations of the UVM classes can be found. We also called some UVM macros. These are defined in a file called uvmmacros.svh, so this needs to be included too. We've got a bit more work to do. We've got the module-based part of our test bench. We can see how that all works because it's just ordinary module-based stuff. But what about the class-based part of our test bench? Where is our top-level test class, myTest, instantiated? What calls the various phase methods? Well, most of this happens behind the scenes and you don't need to worry about it. The top-level test class is instantiated behind the scenes. The various phase methods are called from behind the scenes. But there is still one more thing to do. We need to call a method called runTest and supply the name of our top-level test class as a string argument. As you can see, we have done so on the slide. Calling this runTest method sets everything else in motion. As ever with UVM, this is not the only way to do this, but this is the way we're going to do it in this example. So let's call this runTest method from an initial block in our top-level module, top. And so that this runTest method is in scope, we need to wildcard import the UVM package here too. So now we've written all the UVM code we need for our example, let's have a look at all of that on one slide. You can see that it's quite a lot more complicated than Hello World in C, for example, but hopefully you'll appreciate it needs to be in order to properly represent what's going on in UVM. On the left-hand side we've got the module-based code, SystemVerilog modules and interfaces. In the top-level module we're instantiating the interface and the DUT, and we're connecting the interface instance to the interface port on the DUT. That's all structural, and having compiled and elaborated our SystemVerilog code, when the SystemVerilog simulation starts, it will run this initial block and the runTest method will get called. Remember, this method is built into UVM. It goes away and is able to find the test component myTest using the factory mechanism, and then it creates an instance of our myTest class for us. On the right-hand side we have all the class-based code. Both classes are declared in a package, as we've discussed already. Behind the scenes our build method will get called, which creates our env component, and then our run phase method will be called, which waits for 10 and prints out the hello world message. So let's run our test using QuestaSim. We just compile and run our UVM code in the normal way. We change directory to the right directory. We compile the code using the QuestaSim Verilog command. We initialize the simulation using the vsim command and a switch which allows us to do some extra debugging. And then we run. We don't want to quit because we want to do some other things. As with any simulation, lots of things are output. Let's have a look at the most important things. This line is output by the behind-the-scenes UVM code to show which test we are running. Remember, our test is called myTest. Then, notice here is our Hello World message. We can clearly see the message itself, but the rest of the line also needs explaining. The first element is the severity level, UVM info. This is the severity level because we used the UVM info macro to output the message. Then we are told that the message was produced by line 70 of the file uvmhelloworld.sv at time 10. Then the text in the square brackets is the message ID. Remember, we used the output of the getTypeName method, which is just the class name of the class that produced the message. The next message then tells us that the run phase has finished because all objections have been dropped. Finally, we have a summary of all the messages that were output by severity level and ID. There were 6 messages with severity level UVM info, 1 with ID myTest, and so on. QuestaSim provides various ways to look at your classes. We'll have a look at what is called the class tree. If we select this, we can see our classes. There are many behind-the-scenes UVM classes, but also our classes, myEnv and myTest. And if we expand, for example, myTest, we can see its methods and properties. What does it mean by properties? It means what I have been calling the data members of the class. We can see our env class here, and we can also see many more behind-the-scenes data members. These are data members that are inherited from the UVM test base class.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. You can watch the rest of Matthew's webinar, Getting Started with UVM, whenever you want, by heading over to our website www.doulos.com/od and registering for free. For more free tips and tutorials, visit the KnowHow area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.